Good morning, Michael. I see we now have, we're going to the hospital again, and we're going to have an example.
We're going to do an example. And again, because we want to sort of clear up any confusion we have about this infinity over infinity and the parameter that we're using, we don't have to have the parameter going to infinity, so the little t. We just need the f and g values going off to infinity.
So there is a parameter t for which f and g both become infinity.
Exactly.
And let's see what happens.
So let's do a nice example. In fact, this is a neat example that comes up in a lot of physical examples, even machine learning. You take t times the logarithm of t.
And that's the natural log, so ln.
The natural log, ln. I just call it log because if it's natural, its name should be log. Now, this is not in the form of one function divided by another function. So what we'll do is we'll put log t divided by the reciprocal of t.
So
thing, right?
I guess the point of interest is when t is near 0, this is 0, and this is infinity. So they're minus infinity. So this is basically 0 times infinity. And we've cast it now in the form of, not considering the minus sign, infinity over infinity.
Infinity over infinity, because as t gets close to 0, this becomes 1 over 0, which is infinity. So it's of this infinity over infinity form. There's a minus sign. Let's not worry about that. But to make this clear, we'll write this as f of t, where f of t is the logarithm, and g of t is 1 over t. And we want to take this as t goes to 0. Okay? So these guys, f and g, are becoming infinity, but t is just getting close to 0.
Do we have to worry about g prime in general getting 0 somewhere as t goes somewhere? I mean, there must be some condition on g.
There's a condition on g, and it's pretty simple. G, its derivative, should always stay either positive or always be negative. Or another way to put it, g prime should not be equal to 0. At least around 0, it should not be equal to 0.
Okay.
Turns out f, you don't need a condition on the derivative. It's only g.
Okay, let's see what happens now.
Okay, so we know that we should compute the derivative of f prime over g prime. So f is logarithm of t. What's the derivative of logarithm?
1 over t.
1 over t. So I'm going to write f prime over g prime. This is 1 over t. And what's the derivative of 1 over t?
Minus 1 over t squared.
Minus 1 over t squared. Now, if you stopped here and tried to put zeros in there, you get 1 over 0, which is infinity, minus 1 over 0, which is infinity, minus infinity. So, oh, no.
Yeah,
infinity,
but the denominator is numerator, so flip it.
That's right. I can rewrite this as t squared over t.
And there's a minus
sign, which simplifies to minus t. And what happens when t gets close to 0?
F prime over g prime is going to be equal to 0.
So this equals 0. T equal 0. That tells me what this is going to be close to.
So can we apply this to some other unusual limit?
We can. But let's write this down so that we can say this. So this is, maybe I'll put it here, this is approximately equal to 0 plus at most an error function, depends on t. And the point of the error function is as t gets close to 0, this thing disappears.
Okay.
Okay, nice example.
Yeah.
Let's look at this function, x to the n. Well, a lot of people ask me, what does 0, surprisingly, I say a lot of people, surprisingly number of people ask, what does 0 to the 0 mean?
Well, it depends what you mean.
Exactly.
Like I could take 0 to be a small number, like 1 part in a billion. But any small number to the 0 is 0. So 1 billion,
actually, it's 1.
I mean 1, right? Got launched in a forest of zeros. So when you got 1 billionth of a billionth to the 0, it's still 1. So if we keep going and going and going out to infinity, or not quite at 0 yet, it's always going to be 1.
Right. So if you start with a small number here and put in a 0, it's always 1. What happens if you start with a 0 and put it to like the square root of 0?
Don't know.
Well, the square root of 0 would be 0.
0, yeah, okay.
How about the cube root of 0?
It would be 0.
How about the 15th root of 0?
Still would be 0.
So this would always give you 0. So my way, I get 0. Your way, you get 1.
So who
Fight it
wins?
out.
I'm going to win.
You think you're going to win? Well, here's another way to think about it. Let's look at this function and say what happens as x gets close to 0. Or should I say t? Let's say x. I'm okay with this. X goes to 0.
Okay, so we're going to rewrite this using exponential.
Okay, so I'll put an equal sign and you tell me what I should be writing.
That's going to be equal to e to the x log x.
I'm just going to call it log, not natural log, because log is log, man. Okay,
That's
Now
by
what-
the power rule. So
now what happens as x gets close to 0? What does this get close to?
well, we just did it.
We got 0. So this gets e to the 0. And what's
Which
e to
is
the 0?
1. I win.
You win! Congratulations! Yay!
Wonderful. More examples? Thank you very much.
Great.